Hello everyone, welcome to the OneClass channel. My name is Marlyn. I'm a second year student at the University of Waterloo studying chemical physics and math. Today I'm going to be going through some high school level and college level algebra problems. Be sure to check out the links in the description if you're in need of any extra homework help or would like some one-on-one tutoring. Okay, let's jump in. So the question that we have first is, what is the equation in slope-intercept form when the slope is undefined? Okay. So we know that the slope-intercept form looks like that, and that we have that this is the slope, and that this is the intercept. Okay, and so for the slope to be undefined, we need to really understand what that means. And that just means that we don't really have a slope to our line. And usually the slope would be some measure of, like we know it would tell us that the line is making an angle. So this form would tell us that the line is straight and that the slope tells you how much of an angle it's making. And so if we don't have a slope, naturally that would mean that it's not making any form of an angle and the line is going to be straight. And so that would mean that we don't have a slope, so we're not multiplying x by anything, so it just leaves b. And so that would be the form that y is equal to a constant, or alternatively x is equal to a constant, both of which are straight lines. With no slope. And so for the y is equal to a constant situation, that looks like this. So y is just equal to a constant. And then for the x is equal to a constant, we have just that. Let's say it's equal to the constant d. And so that's it for this question. Next up, we would like to solve and evaluate the first part. And so we have 50 by 41 over 2 by 82 over 3. We can go ahead and cancel out the 2 so that this can become 25 by 41 by 82 all over 3. And that is going to become 84,050 over 3. And that is going to give us a final answer of 28016.6 recurring. And that's it. So that's 28016 and 2/3. And that's it for that one. Next up, we would like to multiply and simplify. So we have x plus 1 over x plus 2 multiplied by x squared minus 2x plus 1 over x squared minus 1. First up, we're going to use the difference of squares here. So we know that a squared minus b squared is equal to a plus b into a minus b. So we get x squared minus 1 squared is going to be x plus 1 into x minus 1. And then we're going to try and factorize x squared minus 2x plus 1. You can just use the fact that x minus a squared is going to give you x minus 2ax plus a squared. That means that x minus 1 squared is going to give us x minus 2x plus 1. So now we just rewrite everything in their factored form. X plus 1 over x plus 2 multiplied by x minus 1 squared. So just write it out twice. all over x plus 1 over multiplied by x minus 1. These two will cancel, these two will cancel, and so my final answer will be x minus 1 over x plus 2. Now let's do our last one. We would like to write the answer without using negative exponents. So we have 1 over x minus 7. And so what we're going to do is that we're going to multiply both the numerator and the denominator by 1. And we're going to set 1 as x minus 7. And so what this means is that we'll get x minus 7 all over x minus 7 squared. And recall that x minus a squared is going to be equal to x squared minus 2ax plus a squared. So we'll get x squared minus 2 by 7 by x plus 7 squared. And that is going to give us x squared minus 14x plus 49. And so we know that 1 over x minus 7 is going to be x minus 7 over x minus 7 squared, and that is going to give us x minus 7 over x squared minus 14x plus 49. And that is it for this one. Sorry, is it x plus 7 or x minus 7? Oh, my apologies. So you can really choose anything as your 1. You can also choose it as x plus 7. In that scenario, we get a different simplification. And then that will become x plus 7 over x minus 7, x plus 7. So this is the reverse of what we did before. This is obviously a difference of squares. So it'll become x plus 7 over x squared minus 49. And that's your final answer. Okay, next up we would like to compute the value of the binomial coefficient 10 choose 8. So we're evaluating 10 choose 8, which may also be written as that. And so we know that when we have n choose k, that is going to be equal to n factorial over k factorial n minus k factorial. And so let's put in our values. We'll have 10 factorial over 8 factorial into 10 minus 8 factorial, and that would be the value of 10 choose 8. This is going to give us 10 factorial over 8 factorial into 2 factorial. And then let's just write out this top one in a form that's closer to this. This would become 10 times 9 times 8 factorial, because you would continue 8 times 7 times 6 all the way down. And this is all over 8 factorial into 2 factorial. These two will obviously cancel out. So this will become 10 by 9 over 2 factorial. And then this will, we know 2 factorial is simply 2. So that becomes 10 by 9 over 2. And then the 2 cancels with the 5. So this will finally become 5 by 9. And that is going to give you a final answer of 45. Okay, next up we would like to evaluate this expression. And so we have log 5, 125. And so we need to remember the rule. We want to find a way to simplify this, right? And so basically what we're looking for is x in the equation log 5x is equal to 125. If we rewrite this in exponential form, that means 5 to the power of x is equal to 125. This is easier for us to think about. We know that 5 squared is equal to 25, and that 25 by 5 is going to give you that 125. And so obviously that is going to be 5 squared by 5, and that's going to be 5 cubed. So that means 5 to the power of x is equal to 125, and that is equal to 5 to the power of 3. Obviously these two have the same base, and that means x must be equal to 3. And that's the solution, that log 5, 125 is going to give us 3. Next up, we would like to factor this expression. So we have x squared plus 4. We can clearly see that there is no formula for this because we only have a difference of squares formula. And so what this is going to mean is we should get a complex factor somewhere in there, and we can confirm this by just using the quadratic formula. So we know that for ax squared plus bx plus c, the formula becomes negative b plus or minus the root of b squared minus 4ac. This is all over 2a, and this would be your roots. And so let's just plug in what we have. Since we have 1x squared plus 0x plus 4, this would become negative 0 plus or minus the root of 0 squared minus 4 into 1 into 4, all over 2 by 1. This becomes plus or minus the square root of negative 16 over 2. Now what we can do is use the fact that the square root of a times b is equal to the square root of a times the square root of b. And so what we're going to do is we're going to rewrite this as the positive or negative square root of 16 multiplied by the square root of negative 1 all over 2. We know square root 16 is going to give us 4, so it's going to become positive or negative 4, and square root negative 1 is a special number called I, so it's plus or minus 4i over 2. And so that gives us the two roots of x is equal to positive 2i, because these two cancel to give you 2, or x is equal to negative 2i. And so when you put that in, you get x squared plus 4 is equal to x minus 2i, x plus 2i. If you wanted to expand this out just to double check, you get x squared plus 2xi minus 2xi plus 2i by negative 2i. And so that becomes, these two cancel, x squared minus, let's pull out that minus, so minus 2i squared. Remember that this will become x squared minus 4i squared. And recall that I is equal to the square root of negative 1. So I squared is going to be negative 1. So this will become x squared minus 4 into negative 1. And that will become x squared plus 4. And that's it. So the purpose of it is to just flip the negative to a positive. So it is technically a difference of squares when you think about it, because your two squared terms are going to be x squared minus 2i squared. Those are your two terms. Okay, next up we want to find the difference in these polynomials. So let's just write it out. We have x to the power 4 plus x cubed plus x squared plus x minus x to the power 4 minus x cubed plus x squared minus x. Let's distribute this negative. That becomes x to the power 4 plus x cubed plus x squared plus x minus x to the power 4. Minus times minus is positive, so plus x cubed. Minus times positive is negative, so minus x squared. Minus times minus is positive, so plus x. Next up, we'd like to group like terms. We can see that we have x to the power 4, x to the power of 3, and we have x squared and x. So let's just put them right next to each other. We have x to the power 4, and don't change their signs, because this is all one statement, no brackets or anything. And then plus x cubed plus x cubed plus x squared minus x squared plus x plus x. And then now we know x to the power 4 minus x to the power 4 will cancel. These two will also cancel. So it'll become 2x cubed plus 2x. We can factor out that x to make it cleaner. And we can actually factor out another x. And that's it for this one. Next up, we'd like to graph this inequality. So y is greater than or equal to 3x minus 1. We need to remember what to do to graph inequalities generally before we remember how to do it for this question. And so we know that if we have y is greater than or equal to some function of x, that means that first you're going to sketch out y is equal to that function. So let's say that's the function. And then you're going to account for the fact that y is greater than or equal to. And so you're going to shade in all of the points of y that are greater than. If it gets a little tricky remembering which side is greater than, just remember that you want y to be increasing because y is greater than whatever it is. And so that is what it's going to look like. If it's y is less than or equal to f of x, of course it's going to be the opposite side. And so yes, it'll still include the line because it's less than or equal to, but that's what it's going to look like. If the inequality doesn't include the function, then we draw a broken line instead to show that we're not including the line. We are only including all points above it. Similarly, if we have y is less than but not including the line, we will again have a broken line to show that we are not including it and all points below it. And that's it. And so now let's do it for a specific function where we have y is greater than or equal to 3x plus 1. So first we want to shade the line 3x plus 1. We know that its intercept is 1, and that when x is 0 and that 0 is equal to. So I know that the function should look something, its slope is positive, so it should look something like this, and this will be the point 1. And this will be the point -1/3. Okay, and then next up, we want to determine all points above that line. So when y is greater than or equal to 3x plus 1. Again, if you're getting confused over the sides, you can just plug in random values. And so let's plug in values of y. Let's plug in 0. So when x is 0, what should y be? And so if you have the equation y is equal to 3x plus greater than or equal to 3x plus 1, when you plug in the value of x, which is 0, you get 4 is greater than or equal to 3x plus 1, 4. The reasoning for that is because I chose a point that was the line itself. Let's choose a point that is a little bit more random, such as x is equal to 2. So you get 3x plus 1 is going to be equal to so I said 2, so 7, right? At this point, when x is equal to so when x is equal to 2, y is equal to 0, just generally on the graph, this point, not on the line, but this point. And so that will become 0 is greater than or equal to 7. This is obviously not true. 0 is less than 7, which means that this side is not the side of the graph that we want. what we will want is actually the other side. And that's just if you have like an issue figuring out what side it is that you should shade. So we've shaded in the correct side, and oops, it looks like I actually did the wrong function. So this is for 3x plus 1, which is a great example. Let's do 3x minus 1. So again, that will have a positive slope that intercepts at -1 instead. And this is going to be 1 over 3. So this is our function. Okay, and then now we want to choose a random point. So for example, the point x is equal to 4 and y is equal to 0. Just plug that into your function. So y is equal to 0 is greater than 3 by 4 minus 1. Let's see if that's true. You get 12 minus 1. So 0 is greater than or equal to 11. This is obviously not true, which means this is not the side of the graph that we want. Instead, we would like this side. And so we have the correct function. We have that y is greater than it, and that y can also be equal to it because the line is not broken. And that's it. Okay, next up, we would like to find two linearly independent vectors perpendicular to the vector v is equal to 2 minus 3, 3. If we write out the other equation for this, it would be 2x minus 3y plus 3z is equal to 0. Sorry, actually, so two linearly independent vectors perpendicular to the vectors v is equal to that, right? So what it means for them to be linearly independent, it means that when I take the dot product of whatever function it is I come up with 2, -3, 3, I should get 0. So if I write out what this will give me 2x minus 3y plus 3z is equal to 0 is how I would like it to be. And so here we have one equation and 3 unknowns, and so we have 2 free variables. And so if we set 3y as equal to 2x plus 3z, which means y is equal to a third of 2x plus 3z, I can pick any numbers that will satisfy this. And so if I put that in, it becomes x, a third of 2x plus 3z, and z. So our two constrained variables, and we've turned our free variable into the form of the variables that we have constraints on. And so now, if we separate this out, it'll become x 2 over 3x plus z and z. And then now we can separate this into x 2 over 3x 0 plus, my apologies, 0 z z. Next up, so now we have our two vectors technically. Next up, we just want to multiply this by 3 to get rid of any of the fractions that we have. So we'll get 3x, 2x, 0, plus 0, z, z. And so our two linearly independent vectors that are perpendicular to the one that we've been given in the question are going to become x into 3, 2, 0, plus z into 0, 1, 1. And so these two vectors are linearly independent and perpendicular to what we have. You can double check by just taking the dot product. So go back to what we had. We had 2, -3, 3.011, and that will give you 2 by 0 plus -3 by 1 plus 3 by 1. And that will give you -3 plus 3 yielding 0. If you double check the 3 to 0 dot 2 -3, 3, you will get 6 minus 6 plus 0 yielding 0. So they're indeed perpendicular to what we've been given, and they themselves are linearly independent. And that's it for this question. Okay, next up, we have log 2 3x minus 7 is equal to 3. First up, we are going to want to rewrite this in a form of log 2 something is equal to log base 2 of something. Let's call this that random shape and this another random shape. That would mean that those two things inside of the log 2's must be equal to each other. And so let's go about figuring out how to do that. We're going to be using the logarithm rule of the fact that log a base a is equal to 1, and that log base a of b to the power of c will give us c log base a b. And so we're going to use that to reverse this into a form. And so we know that 3 is going to be equal to 3 log 2, 2. And I've chosen log 2 because I want it to be in that form. And then lastly, we're going to reverse this into the form of log 2, 2 to the power of 3 is equal to 3. So now let's rewrite what we have. Sorry. So now we have 2 log 2's, which means that what is inside them must be equal. So let's just set them equal. 3x minus 7 is equal to 2 to the power of 3, and that's going to give us 8. So 3x minus 7 is equal to 8. Let's isolate our 3x. So we get 3x is equal to 7 plus 8. That's going to give us 15. And then let's just divide out our 3 to give us x is equal to 5. And that's going to be your final answer. Next up, we will use the properties of logarithms to expand this out. We will be using the fact that ln m times n, let's just use a random log, m times n will be log a m plus log a n. Additionally, we'll be using the fact that log base a m over n is going to give us log base a m minus log base a n. So now we will begin, and we'll be taking ln of x, y over z. First, we're going to apply this one to bring the z out, so it can become ln x, y minus ln z. Next up, we're going to use this one to separate this. So it becomes ln x plus ln y all minus ln z. You can have these in brackets, but eventually it has no effect. It just becomes ln x plus ln y minus ln of z. And that's it. Next up, we'd like to graph this linear equation. We have 2x minus y is equal to -4. So the intercept form is very, very convenient because, as we know, y is equal to mx plus b. This will tell us our slope. And this will tell us our intercept. And so if we just go about connecting those 2 points, because it's a straight line, we'll have our line. And so what we're going to try and do is get this back into the intercept form. And so we'll begin by isolating y, and we get 2x minus 4 is equal to y. Let's just rewrite that. Sorry, 2x plus 4. Yeah, because it'll bring the y over, and then you take the 4 back. And so this will become your equation. That means that we have a slope of 2 and an intercept of 4. So if we draw that, will be, and the slope is positive, so we're going to have a line pointing that way. An intercept of 4. And just check what we have as this intercept. And so that is 0 is equal to 2x minus plus 4. Negative 4 is equal to 2x, which means x is equal to negative 2. So it's going to cross at negative 2 and 4, and then you just connect those points. And that's it for this question. Here we're given 2 equations. We have 2x squared plus 8y is equal to 121.5. And additionally, we have x squared minus 8y is equal to 121.5. How we're going to do this is we're going to add these two up. The two 8y's are going to cancel. So why we're adding them up is because we want to get this equation entirely in the form of one of our variables. And we can do that by getting rid of the 8y. You could also subtract the 2, but you'd have to multiply this by 2. And so this way we get 3x squared is equal to 2 by 121.5. That's going to give us 243. And then now let's isolate the x squared. So that will become 243 over 3. And that's going to become 81. And so if you take the square root on both sides, you'll get x is equal to positive or negative 9. Now we need to find y. So just plug in what we have. 2x squared, which is 81, plus 8y is equal to 121.5. Isolate out the y. So this becomes 162 plus 8y is equal to 121.5. So 8y is equal to negative 40.5, and then just divide out the 8, and that will leave us with y is equal to negative 5.0625. And those are your two answers. X is equal to positive or negative 9, and y is equal to negative 5.0625. And that's it. Okay, so we have 3x minus 2 and 2x minus 3. What we're going to do is we're going to rewrite this so that it can be 3x minus 2, negative 3x plus, 2x minus 3. So we're actually going to leave this alone and just multiply it out. So using FOIL, that becomes 3x by 2x plus 3x by negative 3 plus negative 2 by 2x plus negative 2 by negative 3. And that is going to give us 6x squared minus 9x minus 4x plus 6, which will give us 6x squared minus 13x plus 6. Let's see if any one of those look exactly like that, and the answer is going to be C. Okay, we want to find out which number line represents the solutions to x plus 4 is equal to 2. We need to remember how to work with these number lines, and remember that the magnitude of x is equal to b has the two solutions of x is equal to negative b and x is equal to positive b. And so now if we have x plus 4 is equal to 2, we'll have two solutions, and that will be x plus 4 is equal to 2 or x plus 4 is equal to negative 2. Now just isolate for x. In case 1, that will become x is equal to 2 minus 4, so negative 2. In case 2, that will become x is equal to negative 2 minus 4, and that is negative 6. So your two solutions are negative 2, negative 6, and that is going to be option A here. And that's it for this question. Next up, we are evaluating log 3(9). We need to remember that log of ab to the power of c is going to be equal to log ab multiplied by c, and log a is equal to 1. So we're going to change 9, and remember that 9 is equal to 3 squared, so rewrite that as log 3 squared. Then we're going to use this rule to become 2 log 3, and lastly we're going to use this rule, and remember that this will cancel out to become 1, so the answer is going to be 2. And those are all of the questions that I have for you today. I hope you enjoyed today's Q&A session. If you would like to be notified of when we post again on the channel, be sure to hit the subscribe button and the bell right next to it. If you'd like to be able to post your own questions so that they can be answered during the Q&A, check out the links in the description that will give you access to the OneClass page where the questions are posted. That is everything I have for you today, and I hope